All right, ladies and gentlemen of algebra, this is Miss Bashauer here. Today we're going to be talking about our second lesson in Unit 8. It is called Adding and Subtracting Polynomials. So please go on up here and write down your heading there, and we will get started. I'm sorry. And what we're going to be talking about is this concept of like terms. And we're going to review like terms as we've talked about them before, just kind of way back in pre-algebra or in earlier on in the year. Okay, like terms. Okay, what does it mean to be like terms? And what's going to happen today is we're not really going to be talking about the kind of like terms that are like 2x plus 3x. Okay, that's kind of pre-algebra stuff. We're going to be talking more about today is 2x to the second, y to the third, and then z, and how I can match that up with another monomial that has exactly the same variables with exactly the same exponents so that they would be like terms. Okay, and then we are going to, after we review like terms, we are going to start combining like terms, okay, to add together polynomials. Nothing really different from combining like terms before, except now your polynomials are a lot more complex. Okay, you're going to see stuff that's more like this versus 2x and 3x and 2a and 3a, a little more complex. Okay, and then we're going to have problems in which we have to subtract polynomials. And the only time that that becomes a little tricky is when we see the dreaded parentheses with a subtraction sign in front of it and what that does for this stuff here that's in the inside. Okay, what's going on with this subtraction sign in front of it that we might need to distribute our subtraction sign to those terms that come after the parentheses. Okay, so that is what is up. Let's get started. So this is our first set. We're going to talk about adding and subtracting monomials, excuse me. So what we want to do first is identify like terms. You know, what are like terms? And over here, we have a basic definition of like terms. Okay, so hopefully you got that. Maybe you want to write it down. But remember, like terms are terms that have the same variable with the exact same exponent. Generally we take, because we have a lot of polynomials going on, we have a lot of terms in our polynomials going on, so generally we rearrange things. You know, we make sure that our like terms are next to each other so that it becomes a lot easier to start adding and subtracting things. Okay, remember, lastly, we're just going to simply combine those like terms. So I'm going to start with this example here. 15x to the third plus 6x to the second plus 2x to the third. Okay, three terms. This is a polynomial. What I did first was simply make sure my like terms are together, the x to the thirds, and when I add 15x to the third plus 2x to the third, I get 17x to the third. This 6x to the third over here has no like terms, so he just gets brought down. Okay, so I'm going to give you guys this example here. See if you can give it a try. I'll slide up just a little bit so you can see that last thing that we did. And why don't you guys try this one? Look, the only thing is to just be careful, looking very closely at which terms might be like terms. Okay, we have four terms here. Put things together that can go together and see what actually happens as you get an answer. So hit pause and figure out what this one might be. All right, ladies and gentlemen, hopefully you have this answer here. You're back with me. We're going to get 1b to the third, c to the second. Okay, this is our first term here, and then 4 times b times c. This little guy here has no like terms. Okay, he's got no like terms, so he's all alone. Let me see if I can write that a little clearer. There's nothing over here that's just a regular b with a c. Oh gosh, I'm having a hard time being neat today, ladies and gentlemen. Okay, so the terms that are underlined in black are like terms. The 9 and the 5 together are going to make 14. And then we have a minus 13 here. So that is where that 1 is going to come from. Okay, that's where this 1 here. Now remember, we don't have to put that 1 as a coefficient. It's understood that it's there here. And then 4b to the 4bc. That just gets brought along. Okay, let's keep moving on. Okay, just a quick note on how you may want to structure your problems when you do your homework. You can write these in vertical form. Okay, you can write your polynomials up and down where we align the like terms vertically and add them. You can see here we have like terms here we have like terms, and over here we have our like terms. And then all we have to do is go up and down and add them up. 1 plus 2 makes 3. 4 plus 5 makes 9. And then 5x to the second plus 2x to the second is 7x to the second. Here we have no more like terms because all our terms have different variables with different exponents, so we're done. Or you can do it horizontally. When you do things horizontally, you probably want to take some time to put, this is very nicely color-coded. Both of my red like terms with the x squared are first. Then 4x plus 5x, the blue terms here, and the 1 plus the 2. And then last but not least, obviously, you're going to get the same answer. Okay, so that's just a point of what works best for you. Okay, when adding polynomials, we may see parentheses. Okay, so here we have a binomial here, and one parenthesis, and then a trinomial here. So what is important to look at is what's in between them here. Here we have a plus sign. So remember, when you add, the order doesn't really matter. It doesn't matter what order you do things in. So the parentheses can just come out. Okay, we don't really need to have them in there. They're not really telling us any more than what we already knew. So after I take my parentheses out, now I'm going to start grouping together my like terms, and I actually did that here in one step. I did both of those things in the same step. I took out my parentheses and I put my m's to the second, and then came my regular m term here, and then came just the constants, the 5 and the 6. Okay, once they're grouped together, it's fairly easy to see what my answer will be. Okay, that m to that regular m has no like terms, no buddies, so he stays right where he is. 4m to the second plus 1. Okay, remember we're always sticking a 1 as a coefficient if we don't see one. And then 5 plus 6 makes 11. Okay, so hopefully that makes sense because I want you guys to try this next one here. Okay, so you try this one, see what you get, and come back to me when you're done. All right, I think that you're probably done. Hopefully you have 7xy plus x plus y. Okay, I can go no further with that answer because none of those are like terms, so I'm done. Okay, pretty basic. Next, we're going to talk about what to do when you see this dreaded subtraction sign in front of your parentheses. Okay, what's going to happen there? How can I make sure that I add and subtract things correctly? If you want to take a second and write down this statement here, not a bad idea. Oopsie. Make sure to distribute a -1 when you see a subtraction sign in front of parentheses. Okay, so what's really going on is you have a pesky 1 right there. And that 1 needs to be multiplied by this term here, by the second term there, and then by the last term here. Okay, so we'll go step by step. First, we're going to multiply by -1, the terms in the second set of parentheses. So we have 3a to the 4th becoming -3a to the 4th. We have -3a becoming plus 3a. And then we have plus 1 becoming -1. At this stage, do you really need those parentheses in there? Nah, they could be gone at this stage. I put them in just to prove to see where it comes from, but they don't need to be there anymore. Okay, so now we're talking about basically going back and doing what we've been doing in the slides so far. Let's look for like terms. We have 4a to the 4th minus 3a to the 4th. We have a minus 2a. Remember, the subtraction sign in front of a term is part of that term. So that's not just 2a over here that I underlined. It's minus 2a. And then last but not least, we have -1. Okay, I do like to take a second to put things next to each other because I think it really helps. It makes it easy and clear to see. Over here, you can see the steps as they happen written down, what's going on. And then last but not least, we are going to get a final answer of -a to the 4th power. That comes from this 1 being here, 1 minus 3. We are going to get a plus a, because -2 and +3 make +1. And then last but not least, that little -1 just comes along. Okay? So, basic idea of this slide, just make sure, back up here, that if you have a -1 or a subtraction sign in front of your parentheses, you're doing the distributive property to make sure each thing in that set of parentheses that comes after gets multiplied by -1. Okay, so I'll do a little practice together here first. So what is going on here? I see this negative sign in front, or subtraction sign in front is really what you're going to most likely see it as. Oops. You're going to see it as a subtraction sign in front of a certain set of parentheses. So what's really going on here is I'm thinking -1. Okay, I got a -1 here. I distribute. Get your rainbows in there if it helps you remember, and distribute. Okay, that's my first step. What happens is oops, I made a mistake here. This should be a 2. Sorry about that. Let's fix that before that confuses anyone. Okay, so 4m to the second plus 5 and minus m to the second plus m minus 6. Okay, I have it highlighted there in red, those operations there. You can see how they're changing as I multiply each of them by -1. And then last but not least, I treated it as if it was a m to the 5th. Well, we can, I guess, keep it going one more. That would be a 2. And so then, therefore, what we're going to get is 3m to the second plus m, and then minus 1. So either way, I needed to put that last step in there because I didn't put plus 5 and minus 6. Alrighty, ladies and gentlemen, again, I want you guys to try. Here we are. Just make sure to distribute the -1. Come back to me when you have an answer, and we'll see what it was. And oops, let me erase that as you guys start. There we go. Okay, so go ahead and hit pause and give it a try. All right, ladies and gentlemen, I think that you are back. Hopefully you have 13xy plus x minus 1. All right, this over here is our correct answer. If you have any questions and you didn't get the right answer, go back and try it again. If you're still really not sure how to get that, just write some questions in your notebook there or post them on the Edmodo site, and I will make sure and get that tomorrow. All right, let's move on to our last slide, which is just basically going back over those objectives for today. Do we remember what like terms are? Do we know how to combine like terms when we add together polynomials? Okay. What we're looking at a polynomial, remember, is something with many terms. And then last but not least, make sure we have good current use of what the distributive property is. Let me see if I can write that again. Make sure that we're using the distributive property to correctly subtract. All right, if you feel good about those 3 things, you are all set to go. Remember that addition is going to be very different than multiplication or division. Okay, back in our last chapter, we were we were multiplying and dividing. So we were doing 2x to the second times 3x to the third. And these we can simplify that more because it's a times. Okay, and we can add the exponents on that x. We now have x to the 5th. Okay, make sure you're not doing that today. This is when we multiply. When we add, remember, we're not adding our exponents like we did here. Okay, so just a thing to keep in mind. I'll see you guys back tomorrow.